Okay, hello everyone and welcome to this meeting. Today we have an informative talk about the inbound quality notification and QoE personalization, how providers can enhance user experience, by Professor Sergey Gronsky from IMDA Network Institute, Spain. And this talk, it would be about 40 minutes, and after that we have Q&A. Thank you, Sergey, and welcome to iTech.
Okay, thank you first for the invitation, and I know if we run more than 40 minutes, tell me, I'll try to wrap up. So I know professors like to talk too much. And yes, so this is joint work with my PhD student Leonardo Pironi, and with Farzad and Christine here, and just still a little bit from these 40 minutes on some historical information. Leonardo started his PhD studies and joined my group in March 2020, 1 week before coronavirus outbreak shut down the institute. And when he came, I had something else in plans for him. But he came to me one day and said, well, all this routing, all this network stuff, I don't really like. I want to do video streaming. And so, well, it's my unusual professor who follows passions of students is supposed to tell them what to do, but I haven't researched video streaming for more than 20 years. But let's try. So during this COVID void, we tried to do some work, but then I realized that maybe we'll benefit from some collaboration. This is actually when I asked Leonardo, so maybe we should talk to people who know what they're doing. And then can you think anybody in Europe who is doing good things in video streaming? Said, well, this Christian Timmerer and his group in Klagenfurt seems to be very active and productive, producing good results. So I said, well, I contacted Christian, and my first business trip after COVID was November 2021 over here. Actually, I was lucky to return back to Spain because a week after it was sent, and Austria went to another lockdown, so probably I could have got stuck here without being able to eat or stay in a hotel. So the work was quite, this line of work was productive. So over these years, there were papers coming in Connex and SDI, now in Infocom. So I think definitely we have no regrets on our side. And impressively, Leonardo still wants to be a video streaming researcher after getting a PhD, which his defense should happen within a month in Madrid. So let's continue with more technical introduction. So stealing from René Magritte, this is not kind of an internet. It's not because it's just a picture of the internet, not the internet itself, but unlike many people, from the times I was a PhD student doing networking, thought that, well, internet is some kind of collection of routers connected by the links. But on this level of understanding, you would really be confused to see what works and what doesn't work in the internet, what's possible, what's not possible. For example, if you just imagine this individual routers connected by the links, so you want to deliver things from point A to point B, you use classical Dijkstra's shortest path algorithm and think the packet will go maybe this way. And the reality doesn't happen because internet infrastructure belongs to thousands of internet service providers. So they're interconnected through economic agreements and organized in tiered structure. For example, here you can look at this green ISP on the second tier of hierarchy, and it generates revenue by selling internet access to some tier 3 ISPs, and not being tier 1 ISP cannot kind of freely reach all the ISPs, but has peering agreement with other tier 2 ISPs with whom they can exchange traffic for free. So of course you want to get the traffic and send traffic to your customers because you get the money for the traffic in both directions. Sometimes you can reach other parts of the internet through your peers and their customers. And sometimes you're too small to reach everyone for free. you have to pay money for tier 1 transit providers, and this is your business model. And of course, that affects how information flows through the internet. And of course, internet is an infrastructure, but the technical infrastructure, but the purpose to serve end users, right? And for the end users, internet usually presented as access ISP, right? So customer pays, end user pays money, monthly bills for internet access, allowing to connect through the end user devices, and it kind of hides from the end user point of view all the complexity. So in addition to ISPs, behind this access ISP, there are different entities like content delivery network, CDNs, which also play a prominent role in video streaming. We're now going to talk about it. Cloud providers that quite often have their own apps installed by the end users and running, including for video streaming. So going to the kind of the specific topic of video streaming, streaming platforms provide the over-the-top or OTT services by controlling both ends of the streaming pipeline. So in the data center, the OTT server partitions the video into individual chunks and encodes each chunk in multiple representations, each requiring different amount of bandwidth. And the end devices, the OTT provider has a client running and in particular executing adaptive bitrate or ABI algorithm that dynamically selects the representation for next requested chunk according to own estimates of available bandwidth. And if the bandwidth estimates are too conservative, then the end user views this chunk at a lower quality than possible. But if the estimates over optimistic, then the video stalls because this chunk arrives to the end user device too late for uninterrupted playback. And this undermines quality of experience for the end user. So this is transition to the first part of the talk. So I talk about two individual pieces of work. So this is relatively recent, presented at CloudNet in late November last year. So we talk about quality of experience, which is a concept more kind of common on application layer, but what's the role of ISPs? So ISPs say they're interested in improving QoE for the users, right? And you can trust it or distrust it, but that's a kind of common belief or statement repeated by them, to attract and retain customers, maintain good reputation in network connectivity markets. But also ISPs are in the best position to improve QoE impairments. For example, if there is a stall experienced by video stream because of congestion in network link belonging to an ISP, then ISP have well-known technical means to resolve this congestion. For example, by sending packets belonging to this video stream at a higher priority of the congested link, or by rerouting the video stream around a congested link. Right? So, but before ISP can resolve congestion, resolve the congestion-caused QoE impairment, ISP first have to find out that this impairment occurs. Right, and traditionally, ISPs done it through deep packet inspection methods when they look at the payload of the packets, but more recently, OTT providers, citing mostly privacy concerns, started to encrypt traffic end-to-end. For example, quick for YouTube traffic. All right, and that's actually makes very complicated for an ISP to independently infer that QoE impairment has happened. Of course, the OTT providers who encrypt traffic, they can provide this information to the ISPs, but OTT providers are generally uninterested in providing this support. They prefer ISPs act as dumb pipes and leave QoE management to themselves. So if OTT providers don't help, then potentially the help can come from the entity that is most interested in QoE improvement from the end users themselves. Right? And of course, most of the end users are not really into active support. Actually, we'll talk about it in the second part of the talk about another piece of work where this assumption is questioned. But they're typically willing to install and run applications on their devices. That's kind of the minimal support they can provide. So in particular, for these purposes of notifying an ISP that QoE impairment is going on, there are different tactical proposals which already exist. For example, ALT, or application level traffic optimization, allows to communicate applications with network entities and ISPs. Right? But these outbound QoE ceiling mechanisms don't get much traction. So ALT exists more than 10 years. It's not happening a lot in practice. And at least my explanation why is it happening is because internet, as already mentioned before, is complicated tier structure involving thousands of ISPs. So if you end user running this end user, having this end user device connected to internet, you're aware about access ISP, but you don't have any immediate or easy obtainable knowledge where congestion occurs. And especially with the routing internet, partly affected by economic relationship within an entity, is asymmetric, so it's quite possible that the congestion that affects quality of experience occurs in the ISP, that of the path from the end-use device from the OTT client to OTT server. So in this work, we proposed a new mechanism, which we called in-band quality notification, or IQN, for end users to communicate QoE impairment to the relevant ISPs on the server to client path. And the kind of key observation here that all the kind of modern OTT providers, they want to engage with the users for the various purposes, for improving QoE, but also for improving money flows for themselves. And they provide usually an interactive interface with various features. So the idea here that an agent can be, an application can be running in the end user device that leverages this interactive interface to issue commands to the interface, which results, according to the internal logic of the OTT streaming servers, into distinctive traffic pattern from the server to clients. And in an ISP, in the routers in an ISP, there is another agent running and detects this distinctive traffic pattern in forwarded traffic to infer that there is a QoE impairment. So the attractive feature of IQN that it works in the modern internet with all these realities such as asymmetric routing, network address translation. I didn't mention that in the previous slide, but essentially network address translation, or NAT, means that the network flow that carries video stream is known under different identities to the end user and the routers or the ISPs on the way. Right? So even if end user application can connect to the ISP where is congestion, this ISP and the end user know this video stream under different network identities. All right, so it's not an issue here, and it also works without any explicit support from OTT provider. So you say, well, maybe it's kind of a creative idea, but is it feasible and is it effective? So to investigate this issue, we developed UStol, which is a prototype of IQN for stalls of YouTube video streams. So actually, it's a bit just to develop a prototype. We look not only at IQE signaling, but also on the detection of QoE impairment. And for this, we just did screenshots, periodic screenshots of the YouTube playback area and detected stalls by observing the spinning wheel. And for the main part of it, for IQN signaling, we utilize the autoplay switch of YouTube's interface. So essentially, by toggling this autoplay switch even number of times programmatically and quickly, we make sure that even the YouTube client was sending control packets to YouTube server, and when these packets are sent, then the switch remains in the same position, the cursor remains in position, so it's visually not disturbing for the end user. And in response to these control packets, YouTube server responds also with control packets. And even though the traffic is encoded by YouTube with QoE, and you can see the payloads, these are very characteristic packets with a specific range of their sizes. And of course, YouTube server sends other control packets in the same range, but usually happens infrequently, not, let's say, 4 packets within a small period of time. So this defines a distinctive pattern, which is recognized by ISP agent running an ISP with 2 sliding windows to detect when a stall in the YouTube stream starts and ends. And of course, to close the loop, one needs to also incorporate mechanisms for resolving QoE impairment by the ISP. But as I mentioned, there are well-existing methods for this, prioritization and routing, and that's kind of the direction for future work to implement these techniques to see that it works end-to-end. So to kind of experimentally evaluate this IQN mechanism, we conducted experiments where UStol end user agent was running and the device in Madrid. We tunnel all the traffic from this device to the EC2 instance in Frankfurt. There we wrote UStol's ISP agent and communicated with the YouTube in the wild by considering YouTube live videos of 3 genres, news, music, and sports. While in the typical settings, stalls are not that frequent, we induce 100 stalls per genre by fixing resolution at high value and limiting YouTube traffic to 1 megabits per second. And we use Selenium to collect the ground truth on these stalls. So here in this graph, we saw this ground truth actual stalls in magenta horizontal lines. So that's where there's like instances of YouTube stalls on the end user device. And the black dots in this graph represent these candidate control packets sent by YouTube server to the YouTube client. And you see the detection by ISP agent is quite accurate. So it ignores the irrelevant candidate packets. And when there are a lot of them arrive within a short period of time, it correctly infers stall. So these golden horizontal segments represent the stalls as inferred by the ISP. So in this experiment, we look at the distribution of stall durations for actual stalls and the inferred stalls for 3 different genres. So even though genres have very different distributions for stall durations, for distributions for inferred and actual stalls match very closely. And we look at the durations of individual stalls. We focus on the significant stalls in terms of their duration, at least 400 milliseconds, which are particularly interesting because these are those stalls which affect the user experience the most. And also it's something that ISP can do about to resolve the problem. So here we see that on average the error is 300 milliseconds, so which is relatively low error. So it shows that the mechanism is fairly effective in our implementation. So after quickly showing our responses, let me conclude this part of the talk. So IQN provides automated in-band QoE signaling from end users to ISPs. And it does so by leveraging OTT client's interface. And it achieves this accurate inference of QoE impairment in ISPs without support for OTT provider, despite end-to-end encryption, asymmetric routing, address translation, other realities. We implement uStall to show practical promise of the approach. It instantiates a QoE for YouTube stalls using autoplay switch to signal the stalls. And the cloud-based implementation showed IQN feasibility and effectiveness. So the code for uStall and its instantiation of IQN is on the in this GitHub repository. So IQE is a piece of work presented at Connext 2023. So it's a little bit more than a year ago, and Connext now publishes its articles in the new journal Proceedings of ACM and Networking to kind of satisfy both communities that value journals and conferences. So that actually goes a bit closer to the issue about quality of experience. So quality experience is a subjective measure of how end user comprehends this experience. All right, and subsequently, the most natural and direct way to assess quality of experience is in subjective tests to show experiences to video streams to the viewers, and viewers assess the quality on some scales. So in this particular study, we use the scale from 1 to 100, similar to Waterloo 4 data set on which we started to work. And again, working with users and making users evaluate QoE all the time is time-consuming and problematic for other reasons. So typically, QoE models are used as a proxy of actual user, and is essentially mathematical function that map influence factors or ifs that can be objectively measured into a value. And again, these influence factors could be stall duration, as discussed in the first part of this talk, or image quality, and so on. And traditional QoE modeling is done on the lab or online, but essentially somebody, sampler, selects from larger pool of experiences, subset of experiences, and exposes them to a set of end users to whom we refer raters to identify their special role in creating QoE model, and the individual scores which experience are average in mean opinion score, or MOS, and based on this a set of assessed experiences, their influence factor values and mean opinion scores, some kind of modeler is applied, typically some statistical method like regression, for example, and QoE model is created, And then when the model is created, it can be used at scale, not only for aviation, but also for system design and operation. And many ABS streaming algorithms actually rely on these on QoE models, model predictive control, MPC, PenSieve, and so on. All right, and then when this one-size QoE model is plugged in such QoE-based ABS streaming system, essentially all the viewers kind of get one size fits it all QoE treatment. And the question, is it good for everyone? I think many here in the audience know that not. There are many studies show that different people perceive different influence factors differently. So this is a result from Waterloo Food data set. And it's basically shows on the scale from 1 to 100 for 32 real raters their average score. So there is a big spread. And in particular, if you just take the average rater, essentially the rater represented mean opinion score, it's very different from many of actual individual users, especially atypical. Those are, in this paper, defined as 10% of the overall population. So one size fit QoE model is not accurate, then what can be done about it, right? So the initial approach is specialization, but the question is how to personalize. Of course, the appealing thing is to use some indirect feedback, right? You can observe the user, what the user does, potentially even facial impression, or put some implants in the brain and things like this. But it's very intrusive. Even intrusive methods are not very effective. Well, we can say, well, maybe if one model doesn't work for everyone, you can create many models and associate particular user with a more representative model. But it also have various problems. Actually, evaluation shows limited effectiveness. Or also one approach to generate some generic QoE model and allow the user himself or herself to turn control knobs to kind of personalize for personal experience. But this is also problematic because usually typically end users cannot formulate what works for them or not, whether they prefer no stalls or high resolution. So based on this kind of analysis of the options, we decided to go for a solution which essentially requires to act on feedback from the viewer. The feedback should be explicit. It should be expressible, meaning that the end user, the viewer, can express what is useful, what is effective and actionable, so that it can be used to actual construction of QoE models. So at the end, we say the viewer is the sole rater for the personalized model. The viewer should be sole rater for the personalized model. But the key question that paper answers is, can the specialization be done with a low effort for the viewer? So that's our proposal was IQoE, that try to answer this question with a by limiting the number of subjective tests that the viewer has to perform to a small number. And for this, we use the active learning with two components. So basically, we design our own sampler that selects experiences from a bigger pool of experiences, and the modeler that constructs the model iteratively. So essentially, based on the current model, sampler selects next experience for the viewer to assess, and then based on the answer of the score provided for this experience by the viewer, the modeler reconstructs the model, updates the model to personalize it for the user. You see the timing is quite tight, so maybe I'll try to go a bit quicker and just provide intuition of what we've been doing here. So how to select the samples, right? We want to minimize the number of experiences an end user has to assess, meaning video sequences, watch and score, right? And we want to have it simple and effective, right? So here we consider 350 possible experiences, and we just go for a simple method for random sampling. We see that random sampling selects something which has either no stalls or highest image quality, but other areas of input space. Basically, experiences are not perfect in both stalls and image quality underrepresented. What we call greedy sampling is considered for Euclidean distances in the space of these influence factor values. It already covers this space of input space much better. But if you look at the colors, which here represent actually score provided by the users, you can see that the bad scores, they basically red and orange points, they're underrepresented, and they're dominated by the green colors, which represent high quality of experience. And we wanted to represent bad quality as well for effective modeling. So improved greedy sampling considers distances both in input-output space and it's much more effective, but it's more computationally effective, and we want to do the selection of the next experience very quickly. Right, so basically, finally, our sampler combined two methods. In the beginning, the first 10 experiences selected randomly. Essentially, at that time, you have to cover the space you don't know. You can construct accurate QoE model. After that, we switch to improved greedy sampling. For the modeler, is actually quite simple. We use support vector regression SVR, and we call it the XVR, our model, because it considers extended set of features. All features were shown to be effective using this method of permutation. Feature importance, and how it's, the vision how it's going to work is essentially in this scenario, we consider already OTT providers, streaming service that already does a lot of personalization in terms of content and tracking the users, creating an account. They would do something like this. They offer a user an option to create IQE model and engage in this session and construct the model, and subsequently use these models for personalized streaming for those who opted in. Those who don't want to do this overhead and just they continue to get standard one-size-fits-all QoE model, which drives the streaming for these other users. So we conducted online subjective studies with 120 real viewers. We did it first volunteers, friends and family, and later we expanded to get the scale using microworkers platform. So I know I'm kind of really short on time, and I don't want to probably go too much over. So essentially, we developed a website. Users connected to this website. Over the internet, downloaded the sequences, provided feedback. IQE was selecting next experiences in parallel, updating the QoE models. This is kind of detailed how we generated the experience set using FFmpeg and PARC simulator that look at the 102 network traces 3 ABIA algorithms interface, which we use for the studies, where the slide was used by the end user to select the score for a particular experience. And here we can compare it with IQE with the 10 prominent QoE models based on mean opinion scores. And the performance was significantly higher, not only for atypical raters, which was 10% of the raw population, but on average as well. And the same for, I think for the same for root mean square error, not only for MIE. And here I mentioned that it's IQE is compared to multiple reference group. You essentially associate each rater with a smaller and smaller relevant group. And the point of the graph, essentially, you have to increase the number of group to the number of pretty much end users. Only when the groups become very small, essentially when modeling becomes personalized, this approach is effective in terms of accuracy. And maybe just over here, I conclude the evaluation part, even there are more results in simulations. So essentially, we use 120 experiences in each set of subjective testings. Out of them, the training experiences were limited to 50. Right? We don't know exactly which of them were used, but we can approximate that well, for actually training experience, we know they were taken 7 minutes. Then user typically takes more time just to download, first of all, the experience before playing it out and assessing, then some cognitive load to come up with a score and enter it, potentially even taking some breaks between during the assessment session. So we basically all this accounted, so on average to lead this 50 experience to create personalized model takes about 22 minutes, which we consider relatively low effort. So now kind of skip the simulation portion because it's essentially increases the scale of evaluation by creating something called synthetic raters, which can automatically score many thousands of experiences. And the results, well, first of all, we show the synthetic raters and real raters are correlated, and the results also show that the choices for the modeler make sense. There's some generability of the results, and the overhead is small. So here shows that initially we use random selection of experiences for assessment. It takes no time, pretty much on iteration. Then per iteration time becomes longer, but even from if you have a long sequence of 100 iterations, right, 100 series to select it, it's still relatively small. It's on the order of 50 or 100 milliseconds to select the new experience. So it doesn't really affect the user. So user does notice this wait to update the QoE model and they get a new experience to assess. Again, acknowledging the sponsors for this piece of work. And for this piece of particular second part, the conclusion that is we propose IQE, a new method for personalization QoE model. It relies on active learning, combining a new sampler in the modeler. In the evaluation, we conducted online subjective studies with 120 real viewers, and we enhanced it with the simulations, which I went through very quickly, with parameter sensitivity, generalizability, and overhead. And the results show the significant improvement in accuracy in comparison one-size-fits-all approaches. Basically, accuracy improved 42% for all viewers and 85% for atypical viewers. And I think we believe, even though the user has to contribute active effort by scoring the session, the overhead is relatively small. It's only 22 minutes. And just to conclude, the summary of both pieces. So video streaming is a diverse and evolving ecosystem that has numerous players of different types with distinct interests. And we talk about ISPs, OTT providers, and users in this particular presentation. But of course, there are other entities like CDNs, which are quite relevant, and we leverage in other pieces of work. This evolution driven by new technical mechanisms and business models. So I think it's the system will continue to evolve and provide new business opportunities, but also technical solutions. In the first part, IQN, we propose a new mechanism for in-band QoE signaling that enables end users to communicate QoE impairment to ISPs, and it leverages the OTT client's interface without requiring any support from OTT providers. In the second part, we look at the personalization of QoE models and propose IQE that does it with low efforts. It builds an accurate QoE model for an individual user and relies on active learning to adapt to user preferences efficiently. Okay, and I think that concludes the talk, so hopefully I didn't overrun it too much. So.